What's cracking, my fellow escapists? It's your boy Cypress, and welcome back to another video covering my game console, where we'll be talking about what I've gotten done in the past, honestly, 4 weeks or so for my new game called FLO. The last videos I posted were speed paints, but this week I've got what I think is actually some of the biggest news I've had since I've started uploading videos on this channel. You're going to want to stay tuned for this. I actually have a lot of news, more than I actually have time to make a video on this week. So I'm going to be splitting this video up into 2 parts again. Both videos are going to have crazy news in them. Watch out. But before I continue, you know what I've got to do. I've got to remind you to hit that sub button. You feel me? And leave a like so I know you like to see what I've got going on in my game. So today I want to talk about how I confronted network code for my project. You're going to see a couple new things in this video, such as a new logo, a new load screen, a new character model, and a new start menu. But that's not what I want to cover today. I'll talk more about those features in the other video. Today I want to talk about the farce of tackling network code. So when I first started adding network capabilities into FLO, I thought it was going to be a rather complicated task. But starting out was actually pretty simple. I learned about Photon Engine, which, like Mirror, is another server hosting platform. It integrates directly with Unity C# in the form of a namespace that I can access with various functions and properties. So connecting to a server is fairly simple. It's as simple as hooking a Unity project up with a server using a server key and the free Unity Photon Engine plugin. Then you connect to that server with a script on an active game object in a scene. Surprisingly enough, you only need one line of code to connect to a server. Just call photonnetwork.connect using settings with the start method. Then once you connect to the server, you can inherit from the model behavior callbacks class and use the callback method on connected to master to perform tasks when you actually connect to the server. Here you see I'm joining a lobby with photonnetwork.joinLobby. Then I use another callback method called onJoinedLobby to load a menu scene where I can then create or join a room. Creating and joining rooms is just one simple script too. Here I use a create room and join room method, both public so that I can call them from a button click event in the menu scene. Create room calls the create room method from the Photon Network namespace. It names it whatever text I put in the text field when I click create. Join does similar, except it joins the room with the name put into that text field instead of creating one. Then when a room is joined, the onJoinedRoom callback method loads a scene from my project into the room that I joined. Once a scene is loaded onto the network, I can load prefabs onto the network with the scene. This is one more simple script. I was intrigued when I found Photon Network had its own instantiate method. Since you need to have the prefab in a folder called resources, I got the idea that instantiating on a network is a somewhat different process than instantiating into just a scene. But anyway, that's all you need. Other than that, it works just like Unity's object.instantiate method. Now I'm at the point where I can load 2 clients and have 2 players in the scene. But the challenges don't stop there. That was pretty simple. See, implementation gets a little bit harder after connecting to the server and loading players into the room. Now you have to sync everything, piece by piece. Let me explain. First, when you load 2 players into a scene, you're going to notice something's off when you try to move. Actually, you're going to notice several things, but let's focus on just one. You're going to be able to control both players with either client. So there's a bit more setup. Now you've got to use a photon view component on your player so the client can identify each player that enters a room. Then in whichever script you handle movement, you'll have to reference a photon viewer and use photonview.isMine to discern whether or not the movement code loaded is local to the client. Not only do you have to localize movement, but you also have to sync movement. If you don't sync movement by adding on a photon transform view component, the server will not communicate to the client that another player has moved. Same goes for animations. Localizing cameras was quite the doozy too. When I loaded up 2 players into a room, I had an issue where I couldn't figure out how to have it so each character had their own individual camera. The difficulty lied in how I had originally set up the camera. One camera, one Cinemachine brain being controlled by several virtual cameras. I had a problem where the virtual cams wouldn't find their targets when I loaded the player in. I was using find object of type to find the player and manually set the look and follow targets of the virtual cams, which weren't defined when I already had the camera in the scene by default and wasn't instantiating the player. But when I instantiated the player using that photon network.instantiate method, the player didn't load fast enough for the camera scripts to find the player. I fixed it at first by using find object of type in the coroutine version of Start, but then I still had the problem of not having a camera for any subsequent player that spawned. The answer to both of those problems was to put a camera and Cinemachine virtual camera in the prefab, so each character gets instantiated and has their own camera setup. However, the problem was not fully solved. That gave each character their own camera setup, so now I have two cameras and two Cinemachine setups when I have two players in the scene. After doing some fiddling around, I found out that Cinemachine brain cameras like to follow around any virtual camera that's in the scene. So what happens is, whenever a new virtual camera instantiates into the scene, any camera with a Cinemachine brain will find that new fresh virtual cam and reassign itself to that virtual camera, even if it's not on that player or wasn't instantiated on that client. I've not yet solved this problem, but I have several things I want to try to fix this problem. One, I could put a photon view on the virtual camera in the prefab, and then try to reference the photon view on the virtual cam and use it to stop the Cinemachine brain on the camera from reassigning to virtual cams that are not local to the client. The second thing I could try, which might not be the best option, is deactivate all the virtual cams that are not local to the client. I think this would be a bad option for me because I would have to constantly be checking if there is a virtual cam that is not mine in the scene, and would have to engineer a way to not constantly be turning off virtual cams for every other player in the scene. 3, I could figure out a way to manually set the Cinemachine brain's target virtual cam and set that target virtual cam to the cam in the prefab. That might actually be the best option. So that's where I've left off. I'm going to keep working and implementing these features that will ultimately lead to the launch of my PvP combat game with FLO. Okay, you feel me? Let me know down in the comment section if you have any suggestions on how to approach that bug that I've got with the cameras, or if you have any questions on how to set up networking with your own projects. Hit that like, hit that sub. Peace.